Hi everyone! In today's lesson we're going to be talking about Tekken, or more specifically using math to explain how to be better at Tekken. This is a fighting game that I'm experienced with for over 10 years now, ever since Tekken 4. It was only when Tekken 6 started that I truly wanted to invest myself into getting better. And in fighting games, there's one universal term that everyone needs to learn in order to improve. They're called frames.
They are a unit of measurement used in games describing the amount of time an action takes.
These actions can be anything from moving or throwing a punch. The less frames a move takes, the faster it is. However, the slower a move is, it tends to be stronger in exchange. Simple risk and reward. Nothing illustrates this more than the infamous move, Snake Edge, a powerful move performed by Brian Fury. What makes Snake Edge so well known is that this is an extremely strong move in lower levels of Tekken, and is a well-known skill check. It's a relatively slow sweep that can trip your opponent, but what makes it so powerful is that it can transition into a strong combo.
A lot of characters have a move like Snake Edge, and thus the term is used to describe any move with similar properties.
In order to defend against a Snake Edge, you'd have to be able to predict it, or react fast enough that you can crouch and block it, which is especially hard when playing online due to lag. If you don't know how to defend against it, then it will certainly be used against you.
But if it's so strong, then what's the risk? Well, that's where the numbers come in.
Blocking his move is like stubbing your toe onto the side of your desk.
Using Brian's Snake Edge, for example, it takes 29 frames to land, which is almost half a second. A relatively long time in fighting games.
It stuns them for a bit, and the player can't do anything for 26 frames. This creates an opening for the opposing player for an extremely strong counterattack.
If we compare, a Snake Edge combo can do 74 damage. However, if it fails, it can lead to a Brian player taking 71 damage.
But what can we do with these numbers? Well, let me introduce you to something called expected values. It is an extremely useful concept that I learned and applied in real life, from statistics and probability. The expected value helps give a weighted average for an event using the probability of said event.
So how do you get the expected value? One way to do it is by using the value of the event you're trying to get the expected value for. Then you multiply it with the probability of said event happening.
The capital X in this situation is the value of the event we're applying the probability to. This is a bit loaded for a definition, but let me explain using an example. When you flip coins, the probability of getting tails is 50%, or in other words, P of getting tails is equal to 0.5. Now let's say you flip 100 coins. Since half of the coins will be tails, then overall, when you flip 100 coins, you are expected to get 50 tails. Realistically, you're not always going to get 50 tails. You might get 49, 51, maybe even something as low as improbable as 2. But 50 is the value you are expecting. So when you multiply the number of coins times the probability of getting tails, 100 times 0.5 equals 50, the expected value. Let's use another example. So let's say instead of 100 coins, let's say you do 1 coin. 1 times 0.5 is equal to 0.5. Then you're expected to get 0.5 tails. But there's no such thing as half of a tail, but it is the average value. Now let's apply it to Tekken.
We know a Snake Edge combo can do around 74 damage,
but that's not going to happen 100% of the time. In fact, we're also going to consider the fact that whenever he doesn't land a Snake Edge, he gets blocked and punished. Let's say the probability of a player landing a Snake Edge is 80%, otherwise known as P of landing a Snake Edge is equal to 0.8. And that means the last 20% is going to be blocked, or otherwise known as 1 minus P of landing a Snake Edge.
Applying expected values into this, then on average, the combo does 0.8 times 74 damage, which is equal to 59.2.
Whereas also on average, when they get blocked, and I'm using Alyssa as an example, it's 0.2 times 71 damage, which is equal to 14.2.
This is negative because it describes how the player is not inflicting damage, but rather they are taking damage instead.
Add it together, and when you use Snake Edge, you get an average of 45 damage inflicted to your opponent. However, let's do another scenario. Let's say we suck at landing Snake Edge and the likelihood is reversed. Then the expected value looks like this. 0.2 times 74 plus 0.8 times negative 71. And the answer is negative 42, a negative number. This means when you try to use a Snake Edge, you are more likely to receive damage than give it. This is extremely important. It tells us that the more likely you are at blocking Snake Edges, the more damage the Brian player will take.
This is a risk a lot of players are not willing to take.
At some point in the game, Snake Edges will get easier and easier to block with experience. But when? Let's use what we know. P of x times 74 is equal to 1 minus P of x times 71. By doing this, This equation is telling me that, on average, the expected value of damage when landing a hit and blocking a hit are equal. With this equation, probability is around 49%.
Why did I do this? I wanted to know when it's just as good as it is bad to use a snake edge. Knowing that P of X is equal to 49%, I can infer two things. If a player is able to land a snake edge above 49% of the time, let's say 50%, you're more likely to do damage with a snake edge in the long run. However, if it was anything lower like 48%, the player is more likely to get punished for it, also in the long run.
The applications of expected values are extremely useful, especially when interpreting if the risks and costs are worth the decisions that we make.
It defines playstyle in higher ranks, and not only in Tekken, but in fighting games in general. With bigger risks, there are bigger consequences.
For example, with Snake Edge, it's hard to dodge at first. But with experience and knowledge, the likelihood of you getting hit by it becomes less and less, thus making you more likely to counter your opponent and deal damage.
The more experienced the player is, the more that they know that a risky play does more harm than good.
However, the inverse is also true. Stronger players tend to use safe and weaker moves, ones that are fast and have low consequences. Like a weak jab's damage might not compare to a Snake Edge combo, but at the very least you won't get comboed to death.
Even if you may not have known what expected value was, this is a concept all video game players subconsciously understand.
By winning, losing, or simply just by playing video games, they understand risk, reward, and punishment. Expected value just explains it more concretely, and with numbers.
Endnotes. Thank you everyone for watching this video. It's been a while since I played Tekken, and it took me forever to get that Brian combo off. I've never played him before, and it's crazy how some of you players do it consistently. This was actually the first video that I had in mind, and was what inspired me to make math videos. It's almost been a year since I started, and I'm glad of how much I've done since then. I hope everyone enjoyed this video and my gameplay. Like and subscribe if you haven't, and I'll see you next time.